Hi YouTube, Timothy Unkert here. In this video, we're going to use the change of base rule to evaluate these logarithms. So I have a logarithm with a base of 27 of 81, and I can use the change of base rule to say log, and I'll pick a base. And I want to pick a base that if I multiply that base by itself enough times, I get 27 and 81. And that base happens to be 3. So I'm going to do log base 3 of 81 over log base 3 of 27. And log base 3 of 81 is going to be equal to, well, we have to multiply 4 3's together. So we have to do 3 times 3 times 3 times 3 to get 81. So that's going to be 4 over, we have to multiply 3 3's together to get 27. So if we did 3 times 3 times 3, we'll get 27. So it's going to be 4 over 3 is going to be my solution in this case. Okay, let's try another one. All right, the second one, we have a log with the base of 216 of 36. I'm going to use my change of base rule. I'm going to say log, and I have to pick a good base here. So I want a number that I can multiply by itself enough times to get both 36 and 216. That number is 6. So I'm going to do log base 6 of 36 over log base 6 of 216. Okay, so if I think of how many times I have to multiply 6 by itself to get 36, well, I'll just do 6 times 6. So that's 2 6's. So 2 over, to get 216, I would have to multiply by 6 again, so that would be 3 6's. So this one is 2/3. Okay. All right, the next one, we have log base 625 of 125. So I'm going to do a log, and I got to pick a base that I can multiply by itself enough times to get 125 and 625. So I'll do log base 5 of 125 over log base 5 of 625. All right, so I got to think, how many 5's do I multiply together to get 125? Well, if I do 5 times 5, that's only 25. But if I multiply again by 5, that's 125. So I have 3 5's that I multiply together to get 125. To get 625, I would multiply 125 by 5 again. So that's 4 5's. So my solution here is 3/4. Okay, one more. Let's give it a try. We have log base 16 of 32. So I'm going to write this as the log. And I want to pick a base that I multiply by itself enough times to get both 16 and 32, and that number is 2. So I do log of, not 16, but 32 over log base 2 of 16. Okay, so how many 2's do I have to multiply together to get 32? Well, if I do 2 times 2, that's 4. Times 2 again, that's 8. Times 2 again, that's 16. Times 2 again, that's 32. So that's 1, 2, 3, 4, 5 2's. Over, to get 16, well, I do 2 times 2 times 2 times 2. So that's 1, 2, 3, 4 2's. So my solution is 5/4. Now, let's say you can't come up with a base. Well, you can use the change of base rule with any base. So you could, in a calculator like Desmos or a scientific calculator, you could just do log of 32 divided by log of 16, And if you did that, you would get 1.25. It's usually not going to give you a fraction, but it'll get 5/4 as a number in a decimal, like so. Because you can do any base, now if I just do log, even though when I write the base is 10, but I could do also natural log, and that's a log with the base e. Okay, so that would give me the same thing. I could pick any number, really. I could even do something like silly, like do log with a base of pi over log with a base of pi. The key here is I'm keeping my base consistent. Okay. Hopefully this video was helpful. If it was, please give it a like and consider subscribing to the channel. Also, comment any questions in the comments below. Hope to see you in the next one. Bye.